Hi everyone, my name is Diego Costa and I'll be presenting what's wrong with my benchmark results, studying best practices in JMH benchmarks, which is work done in collaboration with the University of Alberta, the Chalmers University and Heidelberg University. So performance is critical for business efficiency nowadays, and the best example I can show you for it is the Amazon report showed they would lose $1.6 billion a year just if the website slowed down by 1 second. And that has huge repercussions on how we do performance and how we develop software. So we check performance at the code level, micro benchmarks. We check performance at system level, operation level with monitoring. This talk though is only about the code level, so focus on micro benchmarks in Java. So micro benchmarks are great for fine-grained performance assessment. So you can, for instance, profile your critical methods, different workloads. You can compare different algorithms, libraries, and you can have very fine-grained and precise measurements of your performance of your code, even at the statement level. The tricky thing about benchmarks is that they are quite short running. So all of the sources of non-determinism would impact them, such as the operating system, target environment with applications competing for resources. In case of Java, you have yet another major source of non-determinism, which is the JVM. So JVM optimizes code at runtime, which makes it really hard to write sound benchmarks from scratch if you have to account for all the optimization JVM can do in your code. So the community has come up with several solutions throughout the years, and JMH, which stands for Java Micro Benchmarking Harness, is probably the most popular one. And JMH simplifies benchmark creation greatly by, let's say you have a hot method you want to profile. All you need to do is just create a different class, such as you would do with JUnit in a sense, and you use JMH annotations to specify what method is your benchmark, what parameters you want to run your benchmarks on, and then simply call your method that you want to benchmark within. And at the end of the day, like JMH generates all the warm-ups you need, repeats your iteration thousands and thousands of times to mitigate these external factors, and you get an output like this with even some statistical errors analysis that would make you more confident that your benchmark is actually measuring what's supposed to. The tricky thing is that while it simplifies benchmark creation, it cannot really guarantee that your benchmark is sound. As a matter of fact, as simple as this looks, this benchmark is not sound. As you can see, like if you evaluate the score, the execution time is actually unrealistically fast. No benchmark that matters would run in less than 1 nanosecond. And this happens because while I'm calling the method here and everything looks fine, I'm not using the return of this method. So JVM may just analyze this and understand this as a dead code, right? It would eliminate this code away. So my benchmark is basically useless. So a way you could do this is actually you could return the return of your benchmark to JMH. JMH would then trick the JVM into thinking that results actually being used. And this is just one of these bad practices. We selected 5. There are many others in the documentation. And I'm not going to dive into all the bad practices in this presentation because we only have 6 minutes, but you should definitely read the paper because they are very easy to understand, very easy to spot, and easy to fix. And they all affect your benchmarks in a different way. So the scope of our study is given these 5 bad practices to investigate if they actually occur in open source Java projects, and if they do occur, what's the impact on the benchmark results. So to investigate the first question, we need to find them in the code, in an automatic way. So we built a spot bugs plugin that would then identify this in the source code, it would pinpoint that for developers, and you can actually use this in your CI pipeline or in your popular Java IDEs to at least have another check, make sure you're not having these bad practices in your own benchmarks. So we investigate this by mining GitHub repositories. We found projects that use JMH and found about 120 projects that use JMH, and we run our static analyzer on them. And we found that 28% of these projects have at least one instance of the bad practice. And if you look in projects that actually use JMH extensively, you'd see that 51% of them actually are affected, which is quite substantial. And different bad practices occur in different frequencies. Some of them, the one that I mentioned, not using return computation, is one of the most common. But the most common is actually using accumulation to consume values within a loop, which you definitely should look for it because it's actually very frequently found. So the second question is, what is their impact on benchmark results? And to do that, we had to select a subset of the projects that we originally analyzed. We select 6 projects, which are all, if you're familiar with the Java ecosystem, you're probably going to recognize some of them. They're all very popular. And we compare the benchmarks in the original version and after removing the bad practice to see whether this would impact the distribution of the results. And to our surprise, we found that 78% of the benchmarks were actually impacted with large effect size. Then again, different bad practices, they tend to impact benchmarks a different way. For instance, running benchmarks in just one fork, instead of running each benchmark in a separate fork of your VM as you should, can impact benchmarks up to 4 to 5 times in our tests, right? So the difference is quite substantial. And to validate our results, we submit pull requests to the benchmarks we fixed. Most of them were accepted promptly. Developers were quite happy that we fixed their benchmarks. We did get Postgres JDBC that rejected our pull request because they said that they would remove JMH because of licensing issues. So that's the end of my talk. I presented you 1 bad practice, but we actually studied 5. They are actually prevalent in open source Java projects. They impact the results to a great extent. And we validate our results by actually sending pull requests to original repositories. You can check the data. It's publicly available. You can hit me on Twitter. And I'm now in Concordia University in Canada. Also send me an email if you have any questions. Thank you.